Now, as I started, I'm going to create just a micro channel. I'm going to do it very quickly. I'm not going to be worried about the dimensions, just to show you the the operation that needs to be done. For example, I'm going to do a straight micro channel. For example, as you see here, I wasn't able to do it as a straight line, and I'm not considering this the points are coincident or not, because I'm doing this very quickly. But I can do and define all this by, as you can see here, it automatically corrected. So for example, here in the constraints, I'm going to make these 2 points coincident. So I select this point, and then I select this point, then these are coincident here and here, and here also I need to select these 2 points. Then I'm going to make some vertical as this one. Then I'm going to apply some other constraints. For example, I want this uh, line size to be equal as this one, so I'm going to use the equal length. So I select this one and this one. Then equal distance, because I want the distance between these two lines to be the same, the equal the distance between these two other lines. So as you see here, I select the equal distance, then I select these two, and then I select these two, and it automatically makes this correction. So in this case, I guarantee I have some symmetry. Also, what can I do? I can also, for example, if I'm going to show you just very quickly, I'm going to make this so dimension, then I'm going to change it. In this case, it varies with the other, probably because of the constraints that I'm not sure if I define this to be. I'm going to just quickly look. In this case, it is correct, so I don't need to worry about anything. Then I'm just performing here in order to have everything as supposed, and then I think just this last one. So probably this is more than enough, and then I'm going to make sure that everything is fully constrained. So for example, I need to select this and this line. So this sketch is constrained at least in this axis, then I need to do the same for this axis. And as you can see here, everything is in blue, so I'm 100% sure that is fully constrained. Then I'm going to come back to the modeling, then I'm going to create, and I'm going to extrude this sketch. In this case, the geometry that was asked was the sketch. Then as you can see, once again, the operation, in this case I have add material or add frozen. Here I have the depth option. As you can see, there will be always be like extended view of what your depth is going to be. For example, if I change it here to 50, then it will be the new dimension. If you want to change it, you just have to click here, and you can apply symmetry, asymmetric, reverse. In this case, if I want to extrude my sketch to the opposite direction, then I just need to apply this option. In this case, I'm going to use the normal one, and I'm going to make it like 100, so it can be more easy to see. Then what else do I need to do is just every time I perform any create option, tools, or concept, probably you need to do is to click here in the generate, because as you can see here, it is asking to perform an update. So also something very important is that you always need to check that all these operations are with the green tick. So check, sorry. This means that everything is properly performed. So now there is another option that I can do. For example, I can create a new sketch, and then I can create the fluid domain. And as you can see here, it automatically provides a name for my body or my part. And here I have the option to change this solid from a solid behavior or a fluid behavior. In this case, as it's gonna be a microchannel, it is going to be the solid. I also change the name, for example, micro channel. Then it is easier to understand what you are going to perform in future operations. In this case, I'm going to use the tools option and I'm going to use the fill, which will allows me to create the fluid domain without creating a new sketch, a new option of extrude, and then when I change the dimensions in the sketch of the microchannel or in the extrude, the fluid will automatically change. So in this case, I selected, and it also automatically selected the cavity extraction. So I need to select the three faces that will represent the fluid domain. Then I just click in apply and then I click in generate. As you see here, it automatically create a new body. So I have now two bodies, my solid domain and my fluid domain. So in this case, I can change the name here to fluid domain. And then as you can see here, it automatically changed the behavior of the body to fluid. In case this is not a fluid, as before, you need to change it by yourself. For example, right now it's going to be behaving as a solid. In this case, this is a fluid. So right now, as you can see, you just have a microchannel. In this case, it's a straight microchannel with the fluid domain and the solid domain. If you want, you can change it here to a solid domain. It's This is up to you. This is very important that you put the names that you make comfortable to you so you understand when you're performing the post-processing. Something very important right now is, for example, in case you're going to be using Fluent with Fluent meshing and also in the Fluent, the normal Fluent, when you're going to create the mesh, there are two types of mesh that you can create. One is the conformal mesh, which is this one, and the other is the non-conformal mesh. The difference is that the mesh of the, in this case, left body is coincident in terms of elements and nodes in the interface with the body of the right side. So it means that these nodes are going to be shared by the two geometries. In case you want to perform a non-conformal mesh, then the nodes and the elements are not going to be coincident. And how do you make the geometry or the mesh to be either the A option or the B option? In this case, for example, you have different options. One of them could be, for example, as you can see here, if I go to the mesh option right now, I have the solid domain and the fluid domain. So in this case, the mesh that is going to be obtained as a result will be a non-conformal mesh because these two bodies are not sharing their interface faces. So if I want to have the conformal mesh, then I need to select the solid domain and the fluid domain by clicking in the control. Then I have to select the option form new part. And with this option, basically what I'm doing is that the fluid faces and the solid faces are going to be shared. There are other ways that you can do this. For example, one of them could be by activating the shared topology method, and I can also explain it later with a space claim. So one of the options is, as I was mentioning, sorry for the pause, but basically one of the ways is by doing this. The other is, for example, by clicking here in this option, which is in the right side of the generate button. Here, if you click on share topology, then you'll basically need to select what are the parts that are going to be shared these two faces, and then basically you need to click again in generate. So as I perform this first one, I'm going to delete this one. Also, I'm going to leave I'm going to explode because I'm going to make a copy. So when I perform the mesh, you can see the difference of what I'm talking. So also something very important, in this case we finish with the creation of the microchannel, and I'm going to make something else in here, which is the name selection, because this is very important to define the boundary conditions. So as you can see here, for example, I have this option which is called name selection. This is very important, so I can define, you just basically need to select the faces, because these are, in this case, as we are talking about 3D simulation, I'm going to select this face which will represent the inlet of the fluid. So then I just click on generate, and I can also obviously change the name here as inlet. Then I click just in generate, then once again I can click here in name selection, rotate this and select this face, and then change this to outlet, generate again, and I have to do the same. For example, if these two faces are symmetry, I can also uh, right click in the graphics screen and go proximally to the end and click on the name selection, then apply, then change name, then once again generate. If you want to confirm if you select everything or not, for example, you just click here in the symmetry name selection, and as you can see, when the face turns into green, it means that the faces are selected. Now I'm going just to finish. For example, in this case, I'm going to call all these adiabatic. Something very important is, for example, here you don't need to worry about the fluid and solid difference by selecting, for example, all the adiabatic faces for the solid and all the adiabatic faces for the fluid, because Fluent it will automatically recognize which one is from the fluid and which one is from the solid. Everything because you here define what is the behavior of each one of the solid or bodies. So now I'm going just to create a diabatic face, so diabatic, and finally I can create this. In this case, I forgot to click on generate. So as you see, it's very important. Otherwise, I was not able to perform the next name selection. And here, for example, finally, I'm going to create this name selection, which is going to be the heat source. So I'm going to put it heat flux. So as you can see here, I have everything full defined, and in case I want to use this option, I have different ways of create the interface. Also, you don't need to do or perform the nice selection of the interface because Ansys will automatically recognize them. You just need to pay attention whether you use this option or the part option, which is by combining these two. So I'm going to select here a new, and I'm going to create a new geometry by doing this in a space claim. And as you can see here, I have to wait, but I'm not going to explain in too much detail. I'm just going to show you the most important things, such as the shared topology or the as exactly what we did in the design model, which was the component or the part. And as you can see here, it open the space claim. So you have here the sketch options to create as you wish. And here, for example, if you go to workbench, you have this option. When you click here in this shared coincident topology, it will select the faces that are being shared between two bodies. So in the case of the geometry that we just created as the microchannel, the three faces will be appearing as an option. Also, you can create change the way you performing your designs. For example, if it is easier for you to create the design in design model and then you just want to change it to a space claim, in this case I'm going to close this, and as you can see here I'm just going to change from design model to space claim. It is very important for you to know that these changes need to be done with some careful needs to be done carefully, sorry, because the loss of some, in this case name selections or other modifications are very important. So we have to wait till the new geometry is being imported from one model to the other. As you can see here, we have the solid domain and the fluid domain. And what I was talking basically was, if you click here in the share, you can see here that these three faces are going to be the share topology. So you just need to click here in OK, and basically you don't need to do anything else, and you're going to create a conformal mesh. Once again, the conformal mesh is going to be this one, as you can see here. So there are more than one option to create this conformal mesh. The other is, for example, by selecting these two, and similar to what we did on design model, you just have to click here and move to new component. So these two geometries will share uh, uh, the faces in the interface faces. So as you can see here, for example, the shared topology, this is also very important. It's in none, we have to change it to share. And basically we have exactly the same as we have in this the design modeler option. And here you have too many other options which you can see some other videos, or in case you have any doubts or you need something else, you can provide me some comments and I can start preparing some material for that. And this is it for the geometry part, and you can wait for the others. And if you want something more specific, you can send me an email or you can contact me and I can make a new video. Thank you very much.